For this problem, I'm going to show you how to do Gaussian elimination with this system that you see at the very top of the page. First off, this right here is the augmented matrix. So hopefully you can see all I did was I typed in the numbers within brackets without letters or the equal signs. That vertical line right here, that's not totally necessary. I mean, formally it's supposed to be there, but I personally, when I'm working, I actually don't draw it. But I guess technically it's supposed to be there. I don't really care if it's there. But our goal is to make that matrix that I circled become this matrix right here. So that means I want these numbers to become ones, and I want these numbers to become zeros. The numbers I didn't circle, I don't care what they end up being, but I want that diagonal to be ones, and I want the red numbers to be zeros. So to do that, you're allowed to flip rows, which is what I'm going to do on step 1, because I see that row 2 has a 1 in front, and I don't want a 3 top left. So if I just simply flip row 2 and row 1, I get that first number is a 1. So that's one thing I can do. I'm allowed to multiply an entire row by a number. I'm also allowed to add or subtract one row from another. So sometimes you'll do a combination of that when you're trying to get a 1 or a 0. So also, lastly, my method is I'm going to move left to right. So by that, let me erase some markings on my augmented matrix. So by going left to right, that means I am ignoring these numbers to start out. I don't care what happens to those on step 1 or 2. I am only focusing on these for step 1. And then on the next step, I'm going to focus on column 2, or actually, more importantly, these two numbers. Maybe that 1 will stay the way it is, but I'm going to flip rows. Well, that'll become a 1 again. We'll see what happens. And then the very last step, I deal with that number. So it's kind of like a 3-step process. Column 1, column 2, column 3. All right, let's give it a try. So let me get some blank space. I'm going to scroll down some. And I'm going to deal with the matrix you see at the bottom of the screen. So first step, let me go all the way up so I have plenty of room. I'm going to flip row 1 and row 2. And I'll write what I do on the left. So I have a 1, 1, 2, 19. And I have 3, 1, 2, 31. And then row 3, I'm not going to change anything yet. Don't want to get too crazy right away. All right, so next, so row 1 is done. So next, I want to get that 3 to become a 0. So copy row 1. And I want to multiply row 2, or first I'm going to take row 2, and I'm going to subtract 3 times row 1. Because that means I'm going to multiply this 1 by 3, subtract it from this 3, and it's going to become a 0. That's the goal. So when I do that, I get a 0, but it alters everything else, so be careful. Be careful with your steps there. So I get a -2, I get a -4, And this one's ugly. I'd maybe use a calculator. A negative 26. All right, next I'm looking at this number right here. So if I simply subtract row 1 from row 3, that becomes a 0. Pretty nice. No weird multiplying on that one. So I get a 0, a 2, a 0, and a 6. Pretty nice. I need, first step for the next matrix, I need this number to become a 1. So when I do that, first let's copy row 1 down. And I'm going to multiply that row 2, by negative 1/2. And that's going to make that turn into a 1. So times 0 is 0. I get a 1. Times negative 4 is a positive 2. Times negative 26 is a positive 13. Same idea, or actually, sorry, got ahead of myself. I need to make that 2 disappear right here. So if I combine these two numbers, I get a 0. So let's do that. I'm going to add row 3 and row 2 together. And I get 0, 0, negative 4, negative 20. All right, almost done. Last step, deal with row 3. So copy row 1. Copy row 2. And let's multiply row 3 by negative 1/4. And I get 0. Whoops, let's go back to red. 1, 5. And now I can solve this thing. So this tells me z is 5. This tells me y plus 2z is 13. And this tells me x plus y plus 2z is 19. Do some back substitution, and I know y plus 2 times 5 equals 13, so y is 3. Some more back substitution, and I know x plus 3 plus 2 times 5 is 19, so x is 6. And I'm done. I hope that made sense. Ask questions if you have them.